As the name suggests, synchronous motor are capable of running at a constant speed irrespective of the load acting on them. They are machine with high efficiency and they are mainly used in a high precision application. This constant speed characteristics achieved by interaction of a constant and a rotating magnetic field. Just like any other motor, it consists of stator and rotor. The stator core is constructed with thin silicon lamination and insulated by a surface coating to minimize eddy current and hysteresis losses. The stator is wound with a 3-phase winding for specific number of poles equal to the rotor poles. The field coil is excited by 3-phase supply. This will produce a revolving magnetic field which rotates at synchronized speed. The rotor is excited by a DC power supply, so it acts like a permanent magnet, or alternatively the rotor can also be a permanent magnet. The rotor of a synchronous motor produces a constant magnetic field and the stator produces a revolving magnetic field. Assume you are giving inertia in the same direction of RMF. You can see opposite pole of rotor and RMF will attract each other and they will lock magnetically. This means the rotor will rotate at the same speed of RMF, or rotor will rotate at synchronized speed. Synchronized speed can easily derive as follows. This means by controlling frequency of electricity, speed of synchronized motor can very accurately controlled. But if rotor has no initial rotation, then situation is quite different. North pole of rotor is obviously attracted by the south pole of the RMF and start moving in the same direction. But since rotor has got some inertia, the starting speed would very low. By this time, north pole of RMF will repelled by the north pole of rotor, so it will give a repulsive force. As net effect, rotor won't able to start. So synchronous motor are not self-starting. To make synchronous motor self-starting, a squirrel cage arrangement cleverly fitted through pole tip. At starting, rotor field coil are not energized, so revolving magnetic field electricity induced in squirrel cage bar and rotor start rotating just like an induction motor. When rotor achieves its maximum speed, rotor field coil energized. Then pole of rotor get locked with pole of RMF and start rotating at synchronized speed. When the rotor rotates at synchronized speed, relative motion between squirrel cage and RMF is zero. This means zero force and current on squirrel cage bar. Thus, it will not affect the synchronized operation of motor. Synchronized motor will produce constant speed irrespective of motor load, only if the load is within the capability of a motor. If external torque load is more than the torque produced by the motor, it will slip out of synchronism and will come to rest. Low supply voltage, low excitation voltage is another reason to go out of synchronism. A same synchronized machine can be used as synchronized motor or as an alternator. Synchronized motors are available wide range, generally rated between 150 kW to 15 MW with speed rating from 150 to 1800 RPM. That's all about working and construction of synchronous motor.